Okay, hi everyone. I'm just going to make a video going through this new master pattern generator file that I've been working on that brings together a lot of the different techniques we've looked at in using Touch Designer real time to make patterns with the robotic arm. So the first thing you'll notice when you open the file is that it kind of doesn't look like there's much there, right? We've got just these 5 nodes at the moment. So these nodes are called a base or a base. You just in the comp, it's here, it's base, base, and basically think of it like a container or like a folder. I've just started, tidying up the file so that things are a little bit simpler for when we're working in the studio. So I'll go through these one at a time, and then I encourage you to download the file, start playing with it, and really, just change a bunch of values, see what happens, and check in your visualizer what you think it might make the robot do. And that can be a way of experimenting before we're in class and kind of testing out how things go. So let's go through these one at a time. Let's start with this, perhaps the simplest one, which is the original circle. So these go back to what we discussed last week, things that you said you wanted to be able to control in Touch Designer. So first of all, I'm going to turn it on. This little cross thing here is cooking or not cooking. If I forget to turn it on, and if you go in here and everything has a cross through it, it just means you forgot to cook it or, turn it back on. Okay, so let's go inside and have a look. And the first thing we'll notice is that there's nothing happening in our visualizer. And that's just that we have to sort of tell Touch Designer which area that we want to visualize. So as I mentioned in class, I've also put all of the kind of messy parts of our robot mapping and visualizing into another base container here. And hopefully you might not actually have to do anything in here anymore, but I'm glad that we've gone through it so you kind of know what all of this is. We had all of this math, all of these range limits that are there so that we can control where the robot goes and what distance it travels. So I've just gone inside this base, and we can see the address up here. Project 1, if I zoom all the way out, we're in Project 1. This is like our sort of root level, or our root level is kind of here. Project 1 is our project. This is our perform window, which we're not using so much because we're working with the robot. But if I go inside Project 1, you'll just see this address change. If I go inside original circle draw, we can see that we're one layer down. And I'll just go inside the base one more time, and this is the thing that we want to visualize so we can see our robot and our brush. So what I can do here is I just want to match this address here. So I'm at Project 1, and I'm just going to type this stuff here. So original, can I spell, circle underscore draw slash BASE1 slash, just hit enter, and there we go, there's our circle drawing. So I'll just go one level up, and now I want to show you kind of how the controls work. Okay, so I've kind of made them really big so they're very clear. I think one of the things you asked for was the simple ability to move the circle while we're drawing, which for making patterns could be really interesting. So if you look at these keyboard in chops I've got here, I've got, if I press the parameter window, 3 and 4 here connected to what I call pattern position Z, and then I've got 1 and 2 connected to pattern position X. So if I press 3 and 4 here, we'll see we're moving the circle on the Z, and if I press 1 and 2, we're moving it left and right, and if I press R, we reset it. Okay, so that's pretty straightforward. I believe I've also got here the circle scale I've labeled here, which is this constant. So if we make this number smaller, like 0.1, then we've got a tiny little circle, which we can't quite see because the box is in the way. I guess I can make the box smaller so we can see it for a second. Okay, so there we can see our tiny little box. And then and then our LFO, that would be controlling the speed that we're going around the circle. So if I put the frequency lower, we're going around the circle much slower, or if I put it higher, we're going around a lot faster. And depending on the size of the circle, this might be something that you want to play around with a little bit. Okay, so that's the circle, and again, you can play around. You can try changing the circle for another shape, or just I don't know, see what you can come up with. You can also, one thing I mentioned in class, if you want to lock this to the timeline, instead of using the LFO, we can go into chop and we can put in timeline. And if I connect this now, if I just disconnect the LFO and put in the timeline, what you'll see, what we see is, if I go, if I press play now, nothing's really happening. But if you look at the LFO, we can see that the LFO is a number between 0 and 1. So we need to do a little bit of math here. If I press go math, and here, at the moment we've got 600 frames. So I guess our math would probably be something like go from a range of 0 to 600 and convert that to 0 to 1. So that should take our frame range and convert it to the circle. And if we turn off loop here and just say once, what we'll get is we'll just go around the circle once. And that could be perfect, right? So then we could get to the end and we could, I don't know, move the circle down. Why is that not moving down? Hold on. Let me go back to the beginning. Okay, there we go, that's moving. Oh, I had to be playing, sorry. I had to have my timer playing. So we can always move our circle in position and kind of, stop and start again. So this could be kind of an interesting way to kind of introduce a bit more control. We might need to do some testing in terms of like how we stop and start it and when we move our circle. But yeah, so this, I'll introduce this a few times. This is the timeline chop, which basically switches us from something that we just do over and over again to something which just goes for the duration of our timeline. And we can change the length of our timeline here. I could change this to 100 and then it will go a lot faster and so on. Let's put this back to 600. Okay, so I'll just disconnect this and add in my LFO and delete these. Okay, so let's have a look at one of the other networks. So we'll go on now to the pattern generator, which I think is pretty interesting. There's a lot you can do with it. So if I go into my pattern generator and zoom in, and then I'll go into my base 1 again. So here I just want to change this really to say pattern generator. So if I type pattern underscore generator and hit enter. Okay, so now we're on our pattern generator. I'll turn my timeline back to looping. And you'll see that it's drawing some sort of pattern, which we can see visualized here in the middle. The cool thing about this pattern generator are these values sections and the amplitude setting. So if I put, let's just do a little demonstration. If I put a value of 1 and 1, we actually start with a circle. And what we're actually drawing here is Lissajous curve set. I found this great tutorial online that had a Lissajous curve generator, which gives us basically this like library of curves based on 2 signal inputs being mapped on an X and Y axis. And it's a really interesting Wikipedia article just looking at like the relationship between all of these different curves. But if we go back to our generator, if I start to change the values of what's going in from 1 to 2, you'll see that we start getting this like infinity sign. If I put that at 3, we'll start getting these loops, 4, and so on and so on. There's also some other interesting changes you can make. Like if you put these at the same number, you'll end up back at a circle. But some things you can do, like if you do this, you'll probably end up with these like wiggly, like sine wave type of things. But let's just go back to like 3 and 1. If you look at what the pattern actually is, we have what's called a pattern chop, and the type here, we've got a sine curve, and here we've got a cosine curve, and here we've just got a constant, and with a few other bits and pieces, and we've got the LFO, sort of giving us that little bit of movement. But what you can also play around with is changing some of these to other inputs. So for example, if I change the sine to a triangle, we'll start getting this. I might just move it. I've got 1 and 2 connected again here. So if I type 3, we can just move it off the canvas so we can see a little bit more what we're doing. You'll see we get this interesting combination of like straight lines and curves. The only thing you've got to be careful here is that I think if I make both of these like a triangle, we might start getting, we want to make sure that our pattern never makes the robot jump quickly to another position. We need to have looped movements because as you might remember, the robot can't just teleport from one position to another, right? There's a limit to how quickly it can move. So if I go to like a ramp or something, I think we might, I don't know, I found some combinations that were requiring a bit of a jump in the pattern. Yeah, there we go. Yeah, see how it gets to the end there? It's not a loop. So I think we need, here I left this at cosine just so that we should still be looping. Yeah, so we're starting and finishing our pattern in the same place. But again, like, you know, have a play with these. Like if I put this back to 1 now and I put this to, I don't know, like 6 or something, I was finding these really cool like squiggly curves. And I think once we start carving into ceramic or doing line work or scratching into metal, some of these with just, you know, a little offset as we're carving could be quite interesting. You know, so we might carve our line here and then just boom, offset it and carve it again. And if, you know, if the movement is too small, we can always like take some of this movement and change our math and make the movement smaller. And the amplitude here is the amplitude of the curve. So if I set this to like 0.4, you'll see the curve amplitude gets a bit bigger. Okay, so that one's also, I think, pretty great. So let's now go, I might just set these back to what they were before so I remember. So this is sine, and then we were at cosine. And then I'll press R to reset the position of our geometry. And you'll see what's nice is like we don't have to change anything with our visualizer or anything like that. It's all, I've set it up automatically. So all the changes we make one level up are actually sending all the way down to what the robot gets and what our visualizer gets. And that's what these in things are. These in, there's a bunch of them. They are, when you make a container, if you want to access something in your container, you can just put in a new in various different types. If I call this in, like, I don't know, in underscore tutorial, then if we go back to our base, there'll be this new input slot called in tutorial. So that means if we want to send a piece of data into this section, we've now got a little slot to connect it in. So it's a really nice way to sort of keep your file organized and make sure that changes you make in one level sort of flow back down to the next. Okay, so let's go outside of the pattern generator. I'll just turn that off. So we've looked at 1, 2. Oh yes, you asked me to do a mouse drawing one. So this one's pretty simple. I'll turn that on, go inside, and you can see there's almost nothing in this network. And I'll just change our address so we're on mouse draw base 1. So if I just click here and then just change this to mouse underscore draw. Okay. And I must have done a typo, so I've got nothing. Let me just retype that. Mouse draw, oh, there should be a 1, and then base 1 slash, okay, there we go. So this one you can see, it's just following my mouse. This one we might have to be careful with our limits. You know, when we test this, we might have a few issues, but at the moment here, you can see that all I've got, it's very simple. There's a chop called mouse in. If you look in chops, and I type mouse in, and basically it just gets transform X and transform Y. And then I've just done some math, and I've added a constant. So in the math, what am I doing? I think I've actually I've renamed my X and Y just with this touch designer stuff to Z and X. And then I've added this constant, so if I go into the perspective mode here, that's just the height of our brush. So at the moment I've left it nice and high, but of course we can just drop it down 150, 100, and so on. And remember that it really depends on what tool we have in there and sort of what that height is. So I leave it at 200 because that's, you know, pretty safe bet that we're not going to hit the table. Okay, so. And when we use this in class, we might, if I go into the perform window here, okay, I'll have to do a couple more things to sort of make sure that's going out to our perform window. See if I can fix it now, otherwise I'll just come back to it in class. All right, I have to set my switch. Yeah, that'll be, if I go now here and hit my perform window, there we go. So when we perform in Touch Designer, especially when we're using the mouse, it can be good to be out of the network editor and using the perform window. If I hit escape, it'll take me back to the network editor. And for the performing, I just put a switch here so that when we go to this output, which is what our perform window is seeing, we just have to be looking at the right base. Yeah, okay, so that's it for the mouse input. You can see that at the moment it's pretty simple, but of course you could start adding things to these, to some of these channels. For example, as we did in the previous, one of the earliest files, we added some music noise to one of the directions. If you want to do that, I can show you again in class, or you can just kind of experiment with this file, which is, I think, the way you'll learn the most. Okay, so let's, that's the mouse drawer. Okay, so let's look at the video input. I'll turn that on, and I'll turn my switch. I guess I can turn my switch now to 2, so that'll be running from here now. Let's go into the video input, and there I am. Okay, so, oh, I forgot that I appear in this video. There you go. So now I just also need to switch this to video input, input, base 1. Okay, there we go. And this is really adapting a system made by our wonderful Brian Chan, also at AVA. And what this is doing, it's really worth, like, I'll link to his video in the description. He does some really beautiful filtering of the video signal, and I'll show you what it's doing here. When you start this network, you might get a prompt saying that Touch Designer wants permission to see your to use your webcam. That's what this is. So this is just a video device in. Before we did a mouse in, which is giving us, which is in chop because it's channel. It's like numerical signals. Here the video device in is in tops, video device in, and that typically accesses our webcam. But if you have an external camera, you could set that to whatever camera you've got connected. So that could be kind of an interesting interactive device. But I'll just walk you through basically what this is doing. And Brian does a step-by-step, and it works really well, obviously, because I was able to get it to work. But if I do this and I stay still, it should go over here. And then if I go here, yep, it's working really nicely. So the first thing we do is we flip it, and that's just so, like, when I move left and right, I'm not like the opposite of myself. It does a mirror image, which can be really convenient. And then what the cache is doing, cache is basically storing some of the past footage of the video so that Touch Designer can compare, like, the past and the present. And what that's doing is that's turning your webcam into kind of like a motion detector, right? Because if I go out of the frame like this, then it's like nothing else is changing on those pixels. But as soon as I put my hand up, there's something new, and it can compare the past and the present, and that's how we get our motion tracker. It's really, really clever. And so after comparing the past and the present with this cache, basically what Brian's tutorial did is it cleans up the video signal a lot. So here we're basically doing a lot of image processing. We're removing color. We're comparing the difference between the cache and the current input. Putting a threshold, so really now it's like a black and white signal. And then we go to this thing called blob track. And if you see, you'll see these little squares popping up. And that's the blobs of the blob track. Blob track just looks for these areas where something's different. And there's, a bunch of settings here on, like, how big the blob is it should look for, and how small they can be, how big they can be. And basically every time we move, it's going to start making all of these blobs. But see the way this signal's jumping around a lot? Would be terrible for the robot, right? The robot can't just randomly move all over the place. So the really nice thing about Brian's tutorial is what goes on here, this little bit of feedback and this filtering. If I turn these off, I'm guessing we're going to get nothing. Okay. If I turn the filter off, it'll get really jumpy. And this would not work for the robot at all, right? The robot can't move at like an infinite speed. So that filtering, I think it just like interpolates between the previous position and the next position, so that with this Gaussian filter, so that we're not getting this really jumpy movement. And then everything else is pretty similar to before. We're using this X and Y position. The green square here is just so we can see on the camera feed what's going on. And then I'm just taking the exact same X and Y and putting it into the same generator that we're using for everything else. So yeah, what you can do is you can play around with some of the settings here, play around with the sensitivity of the filter. I don't know, just see what works for you. Or connect an external camera, grab a webcam, plug it in, and you might face it, not necessarily, at my laptop, but maybe somewhere where that movement is meaningful. A really interesting one, obviously, when we're working two-dimensionally, would be on the paper that you're painting on, right? So if you paint something with your hand and a paintbrush, then the robot's going to try to paint after you, right? This, or it might not be painting, it could be ceramic, but you're starting what's called a feedback loop with the robot, and there's probably heaps you could do there, or you could just basically wave your finger as to where you want the robot to paint. So, and of course, painting here, it's just an example because it's a way for us to record the motion, but what that substrate turns into is really up to you. Okay, so let's go out of the video input. I'll turn that off. And then finally, the external geometry. This one, it's not perfect. I'm sure there's like simpler ways to do it. This was just the way that I could kind of get it working. So now I'll set my switch to 1, 2, 3, 4, set my switch to 5. And let's have a look inside. All right, so we want to go to blah, 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 blah. Oh, I changed the name of that. Okay, it's not called base 1 anymore. I call it path visualizer. All right, okay, I guess that's just what I have to type in. So this one is going to be called Project 1 External Geometry Draw / Path Visualizer Flash. Okay, so what I wanted to show you, what I made here is actually, because it's Chinese New Year coming up, I got the double happiness character, and all I did is I just, so it's not like a perfect, super automatic process, but basically I typed the character here in Inkscape, and then I just exported it as, SVG, like a vector file. And then in Blender, I just imported the vector file. I imported the SVG, and then once it came in, sorry, I'm pressing way too many buttons at a time now. I turned it. I converted the whole thing into a mesh, into an OBJ, which I then exported. I can show you this process in class. Right. Yep. Then I grabbed the file, which is here. This is our file in. And if you can't see anything, you can just go here, click on the viewer active here, and you can just right click, display options, and I just turned on points so I can see the points. And then with the file in, I've got a transform so I can change its size. Here it's connected to this constant. And then it's kind of similar to the way that we were going around the circle, basically. I just went to a null, took the null to a SOP2, a lookup, and the LFO is just driving us around the shape. And then the rest of it, that's why this is different. I just changed a few things because I couldn't see the double happiness symbol, so I had to just do a little bit of extra instancing and keep everything connected. So I've got the file coming in here again, going, which is being used to instance this cube on a geo, and that was just basically so I could see it. I found it difficult to just be able to see that geometry. I'm guessing just because it's the way I brought in the geometry. So I think this will work. It's not, I think I might find a better way to do it, but I know that we spoke about bringing in external geometry, and I thought I wanted to give you at least something. And the cool thing with this is, like, if you bring in like a regular 3D model, it will also, like, because what I brought in is flat, it's 2D, right? So it's just taking the X and the Z data. But if you bring in a 3D model of a pattern, the brush will actually go up and down over the pattern. And I haven't experimented with this yet in practice, but it also could be super interesting. You know, like if I go into Blender and make like a plane and like subdivide it a bunch of times and then put in a displacement, what I could do is I'll just add some Voronoi noise to this, maybe make this a little bit bigger. So Voronoi noise is just a type of noise here, and here I could make the noise a little bigger. You know, we could put in a 3D pattern like this and see how when the brush goes over this surface, it translates that into 2D. There's probably like a really simpler way to do this in Touch Designer, but it's just the same way that I was using to get like the Chinese character in as a vector file, and it's just another way to play around. But I'm sure as we keep going, we'll think of all sorts of cleverer ways to do this. Okay, so that's our external file visualizer. And that's it. That's everything in this network. So I'll upload this online for you guys to download. And I suggest just going in there and having a play around and changing a few values and just seeing what you get. And just remember that you will need to turn them on here, and that when you're inside, you know, if I go back to the original circle, that you need to change the address in the visualizing part up here so that we're actually visualizing the right part of the network. So in this case, project 1, original circle draw, and then it'll be base 1. So if you just click to the side here, sometimes you can just, you know, change one part. Here I have to change 2, so it'll be project 1, original circle draw slash base 1 slash, and then hit enter. And now we can see, if I press R and put our circle back up the top, we can see our circle, and I've made the circle super small. I'll make it a bit bigger again. Okay, all right, so that's it. I'll see you all in class. Okay, bye-bye.